I'm gonna give you a personal introduction to me, to a very exciting part of my career that has a lot of lessons for us across the semester. And so I've written this, I've labeled this as sort of the management of high technology products, which is close to the book, to the title of the course. And it should be, and I do believe that this case study, this experience that I went through 20 years ago, is a really good introduction to some of the things that I want to share with you about high-tech product management. I was a university professor at UT Dallas, and I had an entrepreneur came to me and was developing a new product for the marketplace in telecommunications. The details of it doesn't really matter, but I let him work in my laboratory with some of his associates. It was not allowed by the university, but that never stopped me before. I just turned a blind eye to all that stuff, and I didn't get caught. It was all to the good. They weren't doing anything dangerous or anything like that. And there were resources for my students, right? These are expert engineers in telecom, and if there's a question, they were there and they would love to answer the questions. So when that company got bought, it got traction at a system company, and got bought by a company called JDS, and which became JDS Uniphase, which is now Viavi, I think, Viavi. And when that happened, a lot of money went into the product line, went into that product. And I just finished my MBA, and I was sort of having one of my many midlife crises. And the general manager of the company had just bought with a war chest, said, "Hey, do you want to be my product manager?" And I said, "Sure." And so I was in that role for about a year, and I took the product from the laboratory into the marketplace through all the reliability testing, through all the customer acceptance. And when I left a year later, we had a run rate of $100 million. So in 1 year, I went from 0 to 100 million in sales, right? So it was a very special time in telecom. It was a great opportunity in telecom, and I learned on the job how to put everything that I had together to make that product successful. And so that became a very pivotal experience for me. And so when another friend started another company, this time backed by Sequoia, which is a top-notch venture capital firm in California, no longer in China. They just exited. Yeah. They asked me to be their director of product management for the entire product. It is, I think a comment on the title is kind of useful. The philosophy was to save the VP levels, not to hire any vice presidents. And so as an early hire at a director level, I was considered, one of the top managers on the senior management team. And the idea was, it was aspirational. I could aspire to be a vice president, or if you were going for your next round of funding, Series A, Series B, Series C, you could layer in the VPs. And in your early, here's another very, very important piece. If your early hires actually care about the titles, maybe they're not good hires, right? Yeah. If they care about the wealth that they're going to create and benefit from through stock options, maybe that is a good offer, a good hire, right? Unless they're too greedy and stuff, but that's a whole other story. So I got a chance to do a Sequoia startup, and I got the chance to see, what that entailed, and that really reinforced a lot of lessons in product management and particularly in the telecom industry. But you're going to see these themes play out all over in almost any engineering discipline. Software, finance, fintech, all that stuff is going to be there. So, start with what technology products do, don't do, what is, where we are. And right off the bat, I'm quoting Davido, gives you an idea of, kind of the reverence that I hold him in. And the essence of high tech is doing new things for new markets. New things for new markets. And so I love that because it's true, but it's also very broad, right? You can go again and again and again and think in terms of what technology has done. And we can go back to gas lighting of cities, in the 1800s, and what that means for new technology and new markets of that. Electricity following, so communications is a field that's 200 years old, 220 years old, at least in the modern incarnation. So if Moore's law is only around for 50 years, city to city, communication technology has been around for 200 years. When was the first transatlantic cable laid? 1858. I mean, isn't that amazing? Talk about a product management challenge, right? You go to your investors and say, we're gonna take this telegraph cable and we're gonna wrap it in oilskin. We're gonna throw it off the back of a boat. And by the way, I need to build a special boat to do it. It failed after about a year. And what do? Built another one. So what I'm getting at is telecoms are real neat, right? And so you can learn a lot from the industry. One of the things about tech products to contrast with toothpaste and so on is this thing called the design win, a stickiness. If Google or Samsung, as a proxy for Google, can capture a user, then that user is likely to remain sticky to that cell phone interface, right? And not migrate from it. And so the only problem with that picture is I'm older than dirt. And the problem that Android has is that all the teenagers and all the kids, college and high school and even before, they're growing up and they're picking iPhones. And so Apple has done some very interesting things to capture a market that's going to be around for a lot longer than I am. Right? So that design win in circuits, supporting a state-of-the-art GPU chip, for example, on a board is a heck of an engineering challenge. Mm-hmm. You've got all the problems of the hardware, how you interface the wires to the chip with the speed that it needs, the clock distribution that it needs, with the noise and impedance matching that it needs, and then you've got all the software, and you've got to figure out how to start this thing up, right? So once you learn that, you're not going to swap out your chip, right? So some of the older chips, 10 years old, are the ones with the highest margin because nobody redesigns their board for cost or a second source. Mm-hmm. They're too busy going on to the next one, right? So this design win, hard to make the first sale, but if you've architected your product, and inherently it's true in technology, you lock in future sales as well. And so a lot of what we will talk about are the implications of that design win. What benefits it brings to you as a company, and what responsibilities it brings to you as a company. You want to be in business. If you made a design win, you want to be in business. right? Delivering product. The other thing I like to say about technology, and this is a little different, this is a lot different from most consumer goods, right? It's got to be the right product to the right customer at the right price at the right time. That's a four-body collision, right? That's four cars in an empty parking lot that have to come together and dent each other's side doors and bumpers and so on. That doesn't happen very often, right? You might get two of them, you might get three of them. Getting all four of them is only done if you really think through how you're going to do that. You asked about case memos. Here are two bullet points and two perspectives on how to write your case memo.
Sure.
Right? So that all through the semester we're going to learn these little tricks, these little things, right? And so the application of, if you read, in what way is Glock the right product? How did they pick the right customer? How did they select the right price? Why did they come along at the right time? Right? So that's a way that you can take a look at that book. Forget about the subject matter that you're killing people with its product, right? Sometimes intentionally, sometimes accidentally. But that's a framework with which you can do this. In what ways was the Glock a design win, right? You might need to take a look at that as you read the book, right? So these are things that are all around you, right? This is a popular book. It wasn't even written as a business book, right? It was written maybe for gun control, right? Just to put things in the historical perspective, right? But as you read the newspaper, as you read the trade magazines, you're seeing again and again tech products and some of these themes on how to get to market. When you start your company, you have to be very intentional about these four elements. Be interested to see what your father thinks about this.
So there are things. One of the things that you mentioned about stickiness.
Yeah.
So that was so I was sitting in on a meeting that he had with a prospective a new business partner here in Austin. Just this June. And stickiness was something that we constantly kept coming back to because the business that we work in, it's not high tech, but it's similar, it's close to high tech, but at the same time it's a lot of services.
Yeah.
And that was quite interesting that the two of them were talking about but if you're able to get customers once, you know for a fact that they're not going away.
Yeah.
So it's about getting that done and delivering that kind of so if we talk about design, I think it was more about the experience that they have. If you're doing things right, they really never feel the need to go away. So they'll keep paying you for the services.
Yeah. So and that's software as a subscription, software as a service. Those are parts of it.
Provided you have a good design, would you consider that this is mostly a marketing problem?
No. And one thing about it is how do you say you have a good design without marketing, right?
Well, you need to have some domain knowledge of whatever it is you're building.
But you have to know the customer, right?
Sure.
So you could have a great design, but you may not have the right customer in mind for that. And so the customer will actually feed back to your design in that context, right? Pricing, right? You may have a great design, but it may not match the price expectations. You may have a great design, but you might be 4 years early to market or 4 years late to market.
Could you just add an example of that? So it's kind of looking at the iPhone Mini that Apple released with the app, I think with the 12. And so the design was great because they had phones of that size earlier. The customers were already buying them. Price was right. The timing was good. Sorry, I think the timing and the product weren't right because no one really bought it. People were, I think the trend was starting to shift towards bigger screens. and so they had like come up with like the plus, and they took mini off. So like there are no more like those mini iPhones that they design anymore, and it's because I think like they realized that like the timing is wrong and the product is wrong.
Well, I just think it reminded me of the 4 Ps of marketing.
It does,
Product and
yeah.
price are right there.
Mhm.
Customer, similar to promotion, and time similar to placement.
Yeah, I stole some of that themes from the 4 part of it, right, from the 4 Ps, the 4 Cs. But I think this is stronger and applied more to tech, personally. But you're absolutely right. I mean, if you can get there from a variety of other places. But this focuses you on four elements. And the other piece of this is timing. Timing is sort of unique to tech. We have to really get good with predicting the future.
Yeah.
And so one of the themes for the spring course is, how do you predict the future? It's easy to predict the future. It's hard to know when that future is going to hit. And yet there are ways of doing that. And so I don't know how much I'll talk about it intentionally in this class, but in the spring, that's a big part of it. If I sit down to design a chipset that's going to be produced in 18 to 24 months, the requirements of that chipset are going to be very different from what I'm hearing in the marketplace today. How are they different? Well, there's what can I take from Moore's Law to understand what the capabilities will be available to me? And then how do I understand what products my customers are building? Their form factors, their inputs, outputs, the right product, right? Here's a different way. If I develop a chipset for that mini, the iPhone mini, and the iPhone mini doesn't sell, whoops. that was the wrong customer. Because if they're not shipping product, I'm not shipping product. Right. So these are things that I think go beyond the 4 Ps and the 4 Cs, personally. But again, your mileage may vary.
Makes sense.
You may think about this differently. And to your point about it's not really tech, this is a pretty broad definition, and you might think about whether or not what elements of that example that you're thinking has to do with that. So I'm going to talk about a failure, and I'm going to go through why it was a failure, and really the failure of this particular Sequoia startup, Cellian Networks, is what reinforced, Eddie, the specifics of these 4 examples. Right? What works, when it doesn't work, and how hard it is to get all 4 of those to come together. Moore's Law for telecommunications, this is what I sort of was talking about. Along about 1800, Napoleon, the emperor, right? He bought a semaphore link, a wooden semaphore link that linked the coast of France to Paris because he was worried about a British invasion. And so this was a wooden armature thing that would basically do semaphore messages from station to station, line of sight, station to station to station. And if you look about it, it's about 1 bit per second. Every clock tick, you get 1 bit of information, transmitted. Telegraphs happened about 50 years later, and there was about a kilobit of information, Morse code and what have you. This was about the time of the laying of the transatlantic cable, the first one. We went to radio in around 1900. Some great stories about the birth of radio and wireless, and David Sarnoff and RCA and Edwin Armstrong and all this other stuff. But you were able to get up to megabits per second, with radio technologies. You went up another 50 years and you went another 1,000. And these are your cable TVs and your copper transmission lines. And then, about 20 years ago, we were pretty much in the optic space, fiber optic cables, and we had gained another factor of 1,000. If you ask me what happened in the last 20 years to here, this slope which is about 3 orders of magnitude every 50 years, has only increased. So this hockey sticks up. It actually goes faster than this historical rate. When I teach comm systems to undergraduates and to graduate students, I say across your career of 40, 50 years, you owe the industry a factor of 1,000. Where is it going to come from? You know, then who knows? I mean, it's amazing. It's an amazing thing. But Stellium, basically, we were basically selling city-to-city links. Took place right around in this time frame. This is a typical nationwide network. This was a company about that time that had started this build. The company was Level 3 Communications. It's since been sold. You can see the goal is to link the major cities and some of the minor cities, and to create connectivity to other continents. The verbiage that you often hear is in this is you link the NFL cities together, right? These are the cities that are big enough and powerful enough to have a major league football team or a major league sports team. Okay? And so this sort of suggests the footprint of your network. I have a small digression that I think is kind of useful. The guy who started this company took financing, and the financing came from a construction engineering company, a privately held construction engineering company called Kiewit Construction, which was headquartered, I think, in St. Louis. And being private and being a successful construction company, they were sitting on a ton of cash, a ton of political power, and a ton of other things. So this build for Level 3 cost $5 billion to build, right? Kiewit Construction gave the first $1 billion to build this. With that $1 billion of backing and a vision and a track record, they went to New York and they raised another $4 billion. So now they had enough money to build the network. The network, primarily, the cost of building this network was not in the fiber optics. It was not in the electronics. It was a little bit in labor, but that's a weird thing. Mostly it was in concrete and ditches and civil engineering. Can you guess which construction company got that $4 billion contract?
Kiewit.
Right? So isn't that kind of cool, you know, how funding was able to get, and then how the perspective of Kiewit, hey, yeah, I mean, if I give them $1 billion, we'll get $4 billion of business back, right? I mean, you can see both sides of the table, how nicely that worked. You know, big deal. It was a big deal. And both sides of the table were aligned. They weren't aligned wonderfully, but they understood each other's incentives, and they both benefited from it. So that's the kind of thinking that you want to have when you raise money, when you start to architect your company. The lesson of product management is being able to cross the table and sit in the other person's shoes and understand exactly what motivates him or her, how they're rewarded, how they're penalized, what keeps them up at night, you know, what it costs to make a right decision, what it benefits them to make a right decision, what it costs them to make a bad decision. So the right product. Definition, requirements is critical. Industry knowledge helps tremendously. We had that at Cellian. Cellian, the founders of Cellian, the founder of Cellian came from Level 3. He was in charge of all their engineering. So he knew what equipment they wanted for their network. So he had in his mind, what elements of the product, what defined the product would be very, very welcome to the next generation network like level 3. I'll talk a little bit about value chain today, but basically it's the suppliers, yourself, your own company, and your customers, right? So he moved from being a customer to being a supplier to the customer. I moved from being a supplier to Celian to being the purchaser of that stuff. So you can see when you're charting your industry experience, when you're charting your career, the ability to work at winning companies all along the value chain in a particular industry segment is quite strong. You learn everybody in the industry after 10 years, 5 years, 10 years, 15 years, and moving around, sliding around brings benefits that are sometimes really good in the short term and may or may not be good in the long term. Generally speaking, you develop a product definition document. This is not a requirements document. This is coming from a product manager, and a product manager is not an engineer necessarily, or if he is like I was, I wasn't acting like an engineer. So this product definition requirement was the what. What did the product do? What did it not do? What systems engineering or the engineering team does is they convert that what to the how. And the last thing a product manager wants to do is force an engineering team to do the how, how they're going to do it. This gets conflated at smaller companies. This gets conflated at a startup. But we were a Sequoia startup, not a small company. Our seed round was over $6 million, and our Series A was over $80 million. We had, at a peak, we had 80 employees, 70 engineers. So it was not a small venture. That would, again, invent complete products. There's that term that will come out across the semester, and drive them to commanding positions in defensible market segments. Does this sound like military? Yeah, it's funny. If you look at that business model canvas, the one thing that's missing from it, and I think this is generational, is my generation was brought up, on World War II movies, on Vietnam War movies. It was a, business was a battlefield, right? And everything was a competition. What sports teams did you play on, and were you brutal about it, right? Yeah. I mean, that's the heritage. If you look at that business model canvas, try to find competitors on it. The whole idea of business as competition, where somebody else wants your lunch and wants to take your lunch from you, is not even there.
Yeah, that's true.
I mean, isn't that kind of, I don't, so if we have a disconnect, a generational disconnect, that might be one of them. Because I do believe that you will always have competition. If you've got a great idea and you're selling it to a valued customer, somebody else is going to want to elbow their way into your world. And you read some of the famous books that came out of this blue water strategy. And blue water is you go fish where nobody else is fishing. Maybe nobody else is fishing there because A, there's no fish, B, because it's impossible to get to, and C, if you do come back with a load of fish, you don't think there's going to be 30 other fishing boats out where you are the next time you go out? Yeah. Product development. So the requirement document is done by engineers, and that's the how, right? And these guys usually go around a couple of times. Execution on details. A product manager's role is to be sort of the headlights for engineering. And so what I would tell the engineering leaders is, if we're driving a car and there's a pothole in the street up ahead, right? If I do my job, I alert engineering to the pothole out there and not there. Because if I alert engineering to the hazard out here, we can smoothly steer around it, right? If I wait too long to identify this problem, we have to swerve. And everybody on the team gets car sick. So that's one of the roles of a product manager. And what that means is you guys are successful engineers because you're focused on the details of the problems. And to be a product manager, you gotta lift your head out of that and go and think about the other way, the bigger picture. And that's the struggle, and that's the fun of this course, is to start thinking in terms of a big picture perspective so that you can see further out the changes and the conflicts and the problems that you're gonna have and the opportunities that you're gonna have. That's what I mean by being headlights for the engineering. Product manager must resolve inevitable conflicts that go between sales and engineering and customers and so on, internally, you know. Software wants to do it this way, hardware wants to do it this way. One stupid thing is we had our product was a rack and it had cards in the rack, and the engineers wanted to label these 1, 2, 3, 4, 5, 6. And the software people, because they were looking at it from the other way, 1, 2, 3, 4, 5, 6. Right? So imagine getting in the middle of that argument. Right? Stupid. We solved it by having a challenge to the software engineers to be able to write the fastest, shortest program to flip those numbers around. And the winner we gave them a gift certificate to a restaurant. How's that for solving the problem without solving the problem? Every day is high stakes decision making, and so you just have to you're just going to have to get used to making decisions with very little information, right? And I'll tell you one of the biggest decisions is pricing. So, and it's the equivalent. How many of you play poker?
Yeah.
How do you decide what to bet? So pricing is a lot like poker playing, right? There's a lot of parallels. I tried to teach my daughter poker this summer, and she was not happy. She recognized the importance of it, but she walked away kind of bruised a little bit. The other one is, how much product do I build? How much inventory do I carry? You know, how many iPhone minis do I produce to have ready for that first blockbuster day where people are lining up around the corner for it? Oh, nobody lined up for that product. Whoops. Educate the sales force, get a jump on it, teach the sales, be able to really nicely articulate to the salespeople the value of what you're bringing. And this is hard because, so oftentimes you're a product manager at a big company, you're gonna have competing products. You're gonna step on each other's toes. Salespeople hate that. Salespeople hate it when they have 3 products that say they do the same thing. So that happened at the company before Sellium, and I got together with the other product managers and we segmented the market out. And I said, good, better, best. You do good, I'll do better, and you do best. And we created one slide that showed the position of that to the salespeople. And boy, they were so grateful. They loved all 3 of us. because we were able to set up, and our bosses were quibbling, our bosses were fighting, you know, but we managed the sales force. And that's what it took. So we all benefited. Supply chain, manufacturing, services, infrastructure, all of that stuff, it comes across your desk. It's exciting. It's exciting, but it's not for the low energy. Reliability, test and verification. Does the product work? Does the product work to the customer's expectations? Two stories there. I mentioned the company that spun out of Texas Instruments to do LEDs, Bob Baer's company, and eventually they come up with a new and improved laser. The product manager of that decided that they would start reliability testing on this laser right from day one. And so when they went to market, they had thousands and thousands and thousands of hours of reliability data, and nobody could match it. Any secondary, third entrant into the market, well, where's your reliability data? Yeah, it might work. You know, the use of hard data and fear was a great barrier for that first mover, right? An alternate story that I went through was when we were selling into the systems company for the small module that we had. It had to work. It had to work at 15 volts, and it also had to work at 12 volts. So we designed the board, and we wired it up, and we tested it at 15 volts. And then we also tested it at 12 volts. We shipped the product, and the company says it doesn't work at 12 volts. And what we didn't realize was, and in hindsight, this was stupid of us, but what we realized is the reason the requirement was there was because voltages will sag. And so they'll start at 15 volts, but during a brownout or doing something like that, it'll gradually go down to 12 volts. And so instead of turning on the power supply at 12 volts and verifying that it worked, you had to lower the power supply. And we spec'd an op amp, and the op amp was too good. And so it caused all kinds of oscillations and problems during that transition down. And that's why it didn't work. So we had to swap out an op amp and fix the problem, but you know, it was embarrassing, and it took two of my engineers 3 days at the customer's site to figure out what was going on and how to fix it. And then rolling out to manufacturing. When you build product, a lot of times you're sharing a resource of a central factory. That's true even if you outsource manufacturing to Foxconn or somebody like that, right? So how do you convince them to spend time on your product? How do you convince them to assign the best people to your product and not to Apple's, right? So all that's part and parcel of management for the products. This was the product, and at the time it was pretty much exactly what the market wanted in terms of capacity. The difference of it was, I showed you the map of assets all over the country. So a single system will go coast to coast. So you've got assets every 100 kilometers along that route. And so if something goes wrong, well, first of all, at installation, somebody's got to drive out to each one of those huts and tweak everything. And be on the phone and say, okay, I'm now going to tweak my potentiometer this way and this way and this way. So it would take weeks to bring the system up to operation. If something went wrong, you had to figure out where it was and drive out there. And if you missed by 100 kilometers, you have to go to the next one, right? So this was the first intelligence system, so that it came up and was deployed instantly. All the software balanced everything, all the pots were done automatically, potentiometers were done automatically. And to prove this, this was our chief financial officer. She was brilliant at what she did, and she didn't know any engineering whatsoever. And she we showed pictures of her sliding in the card and sliding in the card at the receiving end, 3,000 kilometers away, the fiber, and having it come up to speed instantly, right? No technical knowledge whatsoever. So the benefit that brought to the customer was huge. Every system that's deployed now has this. And every system deployed about 5 years after us had this feature. But we were the first in the market. And we brought something absolutely critical to it, but we didn't succeed. The right customer. Choose your customer. That lowers your R&D costs if you know exactly how to focus to a particular customer. If you know exactly how to focus to those 1,000 doctors out of 15,000 doctors, you don't have to worry about, the demographics of the older people. You focus in on the younger ones. Perhaps the younger doctors are more diverse in terms of gender. And so if you architect your product to be as easy to use for one gender than another gender, you have an advantage, right? Mm-hmm. If an older one, the other way around, right? So you can use these kinds of tricks to really affect your speed to market and your cost to market. You can focus your advertising, right? You have definitive channels on how to meet those 1,000 doctors. You can match your service support to their service support needs. If they're younger, they're gonna know certain things and not know certain things. So when you educate them on the use of your product, understanding who they are means that you can fill in the gaps and not waste their time on the stuff they know, right?
Yeah.
If they're younger, this is not true today, but 20 years ago it might have been true. If they were younger, they might be more facile with the computer and the internet today than the older generation. So you might be able to leverage on that 20 years ago. Now I think everybody does. You can use it, but maybe different ways. Be unique in your customer's mind, right? People who love iPhones really love them, and there's nothing else like it, like an Apple iPhone or an Apple Macintosh computer. Doesn't matter if they're right or not. What matters is they know they're right. That's huge. That perception is huge. We only like to deal with realities. Get away from that. Choosing the right customer makes it possible for companies with limited resources to own them, to own those companies, those customers. And we'll see example after example of that in the course. And then, obviously, make your customers successful, because if they don't ship product, you don't ship product. Also notice implicitly in this is that these things don't really talk about consumers. So a lot of what this is business to business. A lot of what tech sales are business to business. The consumer side of it is really just the very tip, just at the very fringe of all that. But if we were selling into AT&T, we were selling into Level 3, we were selling into Verizon, those are businesses. We weren't selling to the customer. Even Intel, with Intel Inside, they weren't selling their chips to the customers. They were selling, their customers were selling the whole package. This is the telecom, datacom value chain. This is another piece of the industry structure, industry analysis. This picture holds in a lot of tech. You can do almost exactly the same kind of picture for transportation. Highway systems, right? So you've got highway systems, you've got bridges, you've got roads that comprise these highway networks. You've got people that run those roads, right? You've got strain gauges and infrastructure that does testing, that looks for, that provides traffic lights and so on. So all the way up and down this, you've got, this holds for telecom, but it holds for a lot of other cases as well. So where you are on the value chain, sort of gives you who your suppliers are, who your customers are, what kind of jobs you have to do, and so on. So thinking through this, helps a lot. And I think, one of the things that for entrepreneurs, young entrepreneurs, is they always tend to think in terms of having a consumer as a customer. And that may not be the right picture. They may have better value, they may offer better value if they sell into a company. Now the lines are a little blurred, everything gets blurred, and that's good, right? If I create an app, who's my customer? Is it the Apple Play Store? Is it the Google store?
Actually, you'd have to pay Apple for the subscription to
To
put your,
yeah.
to put your app on their market.
Yeah.
Yeah.
Yeah, somehow, some way, shape or form. So what's your relationship with them?
They test your product, they make sure it's not gonna break anybody's iPhone.
So they create,
Yeah.
so they have a very, and we'll dissect this in in different cases. What exactly, where exactly they mean, where exactly they fit in. What we saw was these service providers, the AT&Ts, were shifting between AT&Ts and the network providers. And the network providers were level 3. So they would offer their fiber on a subscription basis for banks to communicate securely and quickly, and other businesses. So if the service providers, contact us about specials, then the network providers contact the other companies to offer communication services. The right price. Your costs don't matter, pricing does. Your competitors' costs do. Another thing you can find from the 10Ks, another thing you can find from buying your competitors' products and dissecting them. The customers must view the price as reasonable. But what's reasonable? Right? And so one way to argue that is to provide use cases that show how much cheaper and easier your product is to use, and how they'll save money. That works well in a B2B setting, less well in a consumer setting. There's always been a telecom rule of thumb, which is each generation is 4 times better at the price of 2.5 times. So pricing doesn't scale with performance. It scales with performance, but not 1-to-1. So you can use that. We'll go through some of these other ways. And we'll also think about how your customer makes money, right? So when you sell into Apple Play, when you put in your app onto Apple Play, Apple has a choice on how to charge you. They can charge you a one-time cost. They can charge you a rent, month by month by month, or they can charge you a percentage, right? And I think they do all 3 because they give you a development kit, they sell you the development kit, and I think they also take a percentage at the end sales. So you probably know more than I do, but
what I heard is the development, you get a development account, and that subscription costs, I think it's $90 annual.
Yeah, something like that. I think it's 99 or something. Yeah, but it's kind of like that. That
Yeah.
you get a developer account and you start posting. So you submit your application for review, And once you've done that, that is when like the before approval or anything, you have to pay to make sure that like they will go through a review and put your app on the store.
So what Apple's doing is they're breaking up that price in a way that's advantageous to their customers, you the developers. And they're trying a little bit to match the flow of money from your venture to their revenue stream.
But yeah, another thing that they do is like, so if, for example, your app isn't free, you're gonna charge customers to pay for it, they'll take a percentage of that.
Right.
And if there are like any kind of sales that you make through the app, even if it is free, then they take a percentage of that as well.
So they match their revenues to their customers' cash flows. Right? So this is, these are ways of thinking about pricing. Right? I can ask for a little bit of money up front, or I can ask for, what amounts to a rent that could be infinite. And that could be beneficial to the customer, particularly in health. Right? Health gets rewarded by procedure, by patients. And so big infrastructure items need to be amortized somehow, right? And so how do you choose to do that? I sell a $3 million MRI. Do I take the check up front, or do I take a percentage of fees for each MRI that's run for 3 years, right? Do I do some mix of that, right? So these are ways of balancing your product into their revenue streams. So you've talked to their engineers, you talked to their doctors, you talked to their, you also talk to their financial people as product managers. So we'll get through all that. When prices are set too high, products never fully develop their markets, and it leaves pockets of opportunity for the competition. When prices are set too low, the company gives away profits that are needed to finance the future. Right? So again, is there a quantitative formula in there? Don't price it too high, don't price it too low. Exactly like you're figuring out your poker hand.
But so I actually had a question about that. Like what if you're stuck with like a low price? That you've already you've offered your customer like a low price, and you want to change that.
New and improved.
Okay.
You've got to come up with a new and improved.
Okay.
The freemium for software, right? Yeah. The low end is free, but if you really want full access, you have to pay a certain amount. And then once you've done that, you say even ultra premium, right? Okay. So now this is also getting into something that I've hinted at, which is what is the complete product, right? Mm-hmm. So do you want a service plan with that? Do you want access to our software, our experts to help debug what you're doing, right? Yeah. So where are you? What do you define as the boundaries of your product? Allows you to scale that. That's just one trick. There's a million of them. But again, if you priced it too low, customers, and you're not able to serve the customer's needs, then you've opened up the door to competition too. Would you rather pay more money for a truly better product? And I think if you look around, even with student budgets, there's plenty of examples why they want that, right? In some cases and not others. Started by former network providers, focused on the total cost of ownership, so a complete product picture, risky. Operating complexity, threatened long-term scaling costs, as more and more of these systems were going in. You couldn't have an army of technicians go out there and tweak everything all the time. That just was untenable. Excellent value proposition for 2000. We came up with these really fancy graphics that got me into trouble one day. I didn't have anything to do with the graphics, but we were running out of time, and it's a very embarrassing and touching subject, so I'll leave it alone. One of the things I did do was I came up with the model for running this network, right? And I picked, sort of certain classic, from that map, I picked certain classic cases, and I ran this again and again and again with different things. All the different elements of what we were selling and how to scale and everything. This is not just day one, this is day one, year one, year two, year three, year four. So I got all those numbers and I brought it back to a value in the present called the net present value, which we'll learn how to calculate down the line. So it's a way of handling time value of money, and always having everybody being on the same date, moving cash flows back into ahead in time or back in time. And so you really start to see the costs of everything, and you got to do, and this was honest, right? You got to break out, the current generation versus what we offered as an operating cost. Able to show very frankly where we did really well to cut the costs and where we didn't do well to cut the costs, right? That adds credibility to an educated customer. It informs our engineers what we have to do going forward. One problem with our architecture might be construed as it's still fairly high to maintain.
Yes.
So how do you do that? Well, it's hard to, because you gotta go out to and swap out hardware. And then there's an inherent labor cost associated with that. So, again, good news, bad news. The right time. So, I don't even know if this was actually Wayne Gretzky. There's some controversy about whether Wayne Gretzky actually said this or not, but a good hockey player plays where the puck is, a great hockey player pays to where the puck is going to be. So where's the market gonna be in 18 months, 24 months, 60 months? Predicting the future is important for a product manager. But there's a normal pace of technology growth. Our knowledge in science and technology doubles every 17 years. So that's a 4% compound annual growth rate every year. So things go slow, year by year by year, but you wake up a decade later and you've got miraculous changes. And so that's based on that average flow, doubling of technology. So you can see how this pace, if you're doing more software development, that pace moves very quickly. You do much better than 4%. If you're doing material science, inventing a new superconductor, good luck. That takes forever, right? But you need both. And that's one of the reasons why Andreessen Horowitz is focusing on software, because it's such a huge opportunity and the payback is very quick. It's arguably myopic because at some point they need hardware, right? You can't sell quantum computing software without a quantum computing, without a quantum computer. But they are, they're in the here and now. It's a good business model. It just won't last forever. And you can't. If everybody did it, it'd be trouble. Right? And then the economic forces hit you, and that's what really happened here. Supply and demand, finance. You'll also remember what happened around the time of 2000, which was 9/11. Yeah. And so 9/11 changed everything overnight. And so one thing, it would be oversimplifying to say that 9/11 caused us to crash. But you can't argue not. One thing it did was it drove up the cost of capital because everything became overnight very much more risky. And so the required cost of capital went up. Money dried up because people were afraid of the future. But that was only one. Now, you've got low, high, and medium growth rate in a particular sector. So another example of how you might do an industry analysis, right? Electric vehicles are expected to have a very high growth rate, right? Diesel trucks have a low growth rate, right? So How much investment you do on that tells you sort of where to go with it. Commensurately, required technical improvement across a certain length of time changes as well, right? If it's slow and steady, a low growth, step by step improvement. If you're expecting very, very high growth, you're going to demand a very, very high rate of improvement. And a small VC may focus sort of in the middle case. And they may fund, if they have enough money, they may fund at different parts of the value chain, components, modules, and systems. Okay?
You press the escape button.
I'm still learning this audiovisual. Sequoia was not a small VC. So what they did was they had bets here, they had bets here, and they had bets here. Okay? And we were the bet up here. We were one of the bets at the system level at very high growth, very high technical improvement. And the reality was down here, especially after 9/11, especially after all the other force factors that came out. Basically, the conservatism of some of the service providers. AT&T likes to go slow. They don't like to roll out the brand new technology. That's risky for them, right? They want to make sure everything moves slow. They don't want an outage. They don't want to overinvest because they won't recoup their own profit. So there's a lot of reasons why that kind of happened. And again, testimony is all the stuff we did here became part and parcel 5 years later to other parts of this chart. But you can see how very, very sensible analysis, right? Low, medium, high, technology, value chain. You see how that kind of can be packaged together into an analysis of an industry.
Mm-hmm.
Right? And that's important for product management to be able to understand that. Most startups like to play up here. High margins. This is now margins as a function of operating costs. So startups, very inefficient, right? And they want very high margins to make up for that inefficiency, right? Mature industries, grinding out cost, being counted on by their vendors, being counted on by their customers, they migrate down into here. Okay. So think in terms of commodities, right? Commodities are down in this area. Startups can't afford to be a commodity. They can't afford to compete there because they don't have scale. They don't have things. So this also sort of tells you, kind of where you want to be, and inherent in this is the risks associated with that. This is well known. This is not. An example I used to use is a printer. I want to be a small printer in a particular neighborhood or city, right? I buy a new press to run off the paper. Hugely expensive, right? My operating costs are very high. I want high margins, but I've got printers already in town that are running their printers that are 30 years old, and they'll eat my lunch. So I have to come up with a new approach to printing in order to be able to enter that market. Maybe the approach is a better screen on your laptop or your cell phone so that I don't have paper. So then this photonics bubble bursts. Scarcity of fiber first drove investment. Many new entrants at the network operator. and where we were, the service provider, at the service provider level, similarly at the systems and at the components, there was supply and demand pricing pressures. In other words, the industry had so much, our customers had so many places to buy from that, you know, it was, there were some winners and there was a couple winners and a lot of losers. They really were able to beat on pricing. And, you know, so they had very specific targets there, and the targets were not for the newer startups. And so the right time was a problem. So we wanted to be up here, but competition drove everybody down to here. Margins eroded. We no longer look good to our investors, who basically were taking a winner-take-all attitude, and had funded across the board, so they were going to win somewhere in their portfolio. And VCs, very generous with their money, and very quick to cut you off, as they have to be. So, here's what happened. 2000, and then the dip. So we were playing right in here. We didn't know it at the time. Everyone said we would be going like that. Instead, we went like that. You'll also notice that it really didn't. Yeah, I mean, it wasn't catastrophic, but it was catastrophic in supply and demand, right? I often say that technology is the end of the whip, the last bit to go up and the first bit to go down in a market. So yeah, 4 years, $70 million spent, maybe I think it was closer to 80, bankruptcy. However, virtual all long-haul transport systems adopted all the features, plug and play, remote monitoring, auto tuning, all the others. And Mike Gogan, he was the managing partner of Sequoia, and he was the chairman of our board. He was a very powerful guy back in the day. If we were in the market today, we'd be selling a lot of products, as we said, when I ran into him around here. All right, so that's the introduction to the course, by way of a sort of a failure analysis. So I'll leave it up to you guys. Do you want to break and come back and talk about the case? Do you want to go on your way and we can pick up the Verilight case another time and we're another day? How do you want to? I went a lot longer than I thought I would with the syllabus and with the
We can talk about it briefly if you guys.
Yeah, I can do it, yeah.
Okay, awesome. I was trying to be polite by way of whether or not you've done your homework.
Since it was a really interesting video lecture, I guess, or a presentation.
Yeah. And the thing is, like, I could see like a lot of similarities with Celio, like when he talked about like 2001 crash, like I think like the 9/11 like also causing like a similar crash for them.
He got me when he told me, when he said his clients were the Bee Gees, Led Zeppelin, and Paul McCartney, he got me there.
Yeah. It was like a small little band of like, let's
Talk about small clients.
Had you actually heard of them? How do I get
And also like the fact that like, you know, like they did the first Beatles like performance.
Yeah.
In the US, God damn it.
The canceling of Paul McCartney's trip to Japan.
Oh yeah.
That was funny.
It's like, that happened and then like, it was like, oh yeah, like that must have, like that would like, oh shit, like stuff like this impacts so many other people. And like the only thing in the news is, oh well, Paul McCartney could, like had some weed.